Robots optimize production worldwide and in nearly all industrial sectors. Their use reduces production costs, enables highest quality standards, and innovative products. Robots are the key to the competitiveness of the industry. They have previously been separated behind safety fences, but thanks to technical advancement, they now work increasingly hand in hand with humans. As useful little helpers, robots are also on the move outside the factory environment. They are available in all imaginable shapes, designed to carry out a wide range of tasks. Robots that perform services for humans are called service robots. In the future, they could play a role in almost every area of life. Experts expect a booming industry.
Service
robotics has been a growing market for years, and at the present time it shows a strong momentum because big players are entering the market, like recently Google. As a result, many investors and component manufacturers are also becoming aware of the industry. There are good reasons for this. A key challenge for the often mobile service robots is their ability to move around in different environments autonomously. However, they must not become a source of danger and never collide with people or things. Fast camera systems, versatile sensor technique, and innovative navigation, drive, and control technology make mobile robots become flexible and secure helpers. They find their way autonomously in unstructured environments that they are unfamiliar with and can also recognize, interpret, classify, and track objects. Stockbot, for example, moves every night through a fashion department store. Its task is to take inventory of all goods and determine whether everything is in its proper place. In the morning, it passes on its collected information to a person. This cleaning robot should above all move around quietly and not bother anyone. It cleans the floor, does not forget any area, and organizes its work nearly independently. Its colleague, however, has to find its own way in a hospital and transport cabinets. When called, it transports them from one place to another. The challenges here are completely different: finding the cabinet, positioning it properly, lifting the cabinet, driving it to the target place without bumping into anything, then setting down the load. Other mobile robots follow fixed routes. Autonomous route finding need not necessarily be their strength, but instead they reliably pick up and carry the required materials. Service robots with so-called mecanum wheels are considered to be particularly flexible. They allow maximum movement variability and precision in a two-dimensional space. Overall, the size, construction, and performance of a service robot vary depending on the tasks at hand and fields of application. How a service robot must move is always a question of its tasks. If the tasks, for instance, have to be carried out in unfamiliar areas, it may make sense that the robot is controlled by a human from distance, for example, in danger zones. In the air, a service robot could even serve as human eyes. Technical conditions like a safe human-robot collaboration or autonomously navigating vehicles contributed to the breakthrough of service robotics. With this also considering the economic aspects, new reasonably priced solutions in logistics, entertainment, and medical technology can be realized. Another important innovation for the industry is the so-called lightweight robots. By reduction of weight, the variability in mobility has increased, as well as the variety of applications. Carbon fibers or high-tech plastics are used so that overall energy consumption could be significantly reduced.
Leichtbaurobotik hat den Vorteil.
Lightweight robotics has the advantage that it, of course, allows the robot to carry out tasks that perhaps have not yet been possible in industrial robotics, such as building, cleaning, intralogistics, or inspection applications and repairs. And for these applications, it is absolutely necessary to have a weight reduction.
Gewichtsreduzierung zu haben.
In principle, there are no limits to service robotics. Thanks to state-of-the-art technology, innovative sensor technique, fast camera systems, and image processing, service robots can perceive their environment, meaning see, hear, and feel it. They can even feel out surfaces and analyze odors. In research, first series of tests on domestic helpers are carried out. Someday, Carobot will be able to carry drinks and ensure, for example, that the elderly will not forget to drink enough liquid.
Hallo, ich bin Carobot 3. In dieser Woche unterstütze ich die Pflegekräfte bei ihrer Arbeit. Frau Ebner,
Ja,
Sie möchten doch bestimmt etwas trinken.
Ja, so.
Ein Schluck Wasser kann doch nicht schaden.
Ja, da hast du recht. Prost, Nachbar. Prost.
Na denn, Prost!
Prost, oder Leben.
On request, the service robot could also carry medication. In case Carobot is not quite sure what to do because it cannot clearly identify an object, it would involve people from the telephone switchboard who would take a look at the object in question via the integrated camera and make the right decision. Also, in case of falls, Carobot could analyze the situation and organize help.
Ich kann mich nicht drehen. Ohne Hilfe geht's nicht. Hallo.
The service robot could explain the function of the blood pressure gauge to people without ever losing patience. It could even forward the measurement results to a laboratory for analysis that could react immediately in case of emergency and send human help. The medical sector is already one of the major fields of application for service robotics. Here, precision and reliability are particularly important. In Wiener Neustadt, one of the most modern centers worldwide for ion therapy is being built. Up to 1,400 cancer patients are treated here annually. For the precise radiation of the tumor, a ceiling-mounted robot is used. Originally, this robot was used in the industrial sector. The patient positioning system developed by BEC aligns the patient with maximum accuracy. With this, treatment of tumors with the accuracy rate of a sub-millimeter became possible. The robotic patient positioning system has 7 degrees of freedom, and for the first time that enables us to really make optimal use of the advantages of ion therapy. One of the advantages is the high level of precision for applying radiation to the tumor. A high precision positioning of the patient is necessary, and this is achieved by the system for the first time. In the background of the therapy, gigantic apparatuses are at work that have been developed in the European Organization for Nuclear Research to accelerate particles. The ring accelerator of CERN is considered to be the origin of this technique. The stiff flop arm could also revolutionize medicine. Only 12-millimeter diameters are required by the robotic arm to perform a minimally invasive operation accurately. Comparable degrees of freedom have not yet been possible with this operation method. We see the particular success of service robotics in different applications of medical technology. Sensor-based, safe, and sensitive robotic assistants will enter this sector, especially in the U.S., already the largest medical technology market in the world. Service robotics will be successful. With new technology, service robotics even enters completely different application fields. Andreas Margreiter developed a revolutionary camera system from a lightweight robot arm. The new technology carries with its own weight of just 14 kilograms, a camera with the weight of up to 12 kilograms, and is able to move it at 2 meters per second anywhere in the room. The cinematic results are unprecedented.
Das Kamerasystem,
The camera system that we developed is based on a 7-axis system. And one of the really important features is that you can make it a manual recording. That means you can activate the robot, you can move the camera freely throughout the room, and you can also record the whole thing, meaning you give it a starting point and you record it.
Startpunkt und ich zeichne das auf.
The camera is able to repeat the once learned movements at any speed. Intelligent software and precise movements enable impressive and previously unthinkable shots.
Um das überhaupt möglich zu machen,
The development of the robotics arm made this possible. It has 7 axes, torque sensors, and therefore feels the movements that impact on it. That means all forces affecting it from the outside are directions of motion for it, causing the robot to move accordingly. And we record these data and can manipulate these data.
diese Daten auf und können diese Daten manipulieren.
Service robots also conquer the entertainment sector. They allow for carousel rides or virtual skiing without any risk of injury, sunburn, or cold feet. Even professionals are enthusiastic. Of course, you can also play against a robot. There is hardly a form that a service robot can't adopt. The exact movement of the puck is calculated by a camera and software in advance. But there are also applications that invisibly influence our everyday life up to now. In cowsheds, mobile robots have been in use for years. They help in feeding the animals and in the stable. So-called milking robots take care of the gentle and effective extraction of the milk. Brushes massage the teats of the cow, and scanners measure the udders so that the suction cups can be placed precisely and carefully. Many applications for service robots are already widespread. Others exist as prototypes. Research and tests are conducted, and new areas of application are discovered. It's merely a matter of time before ideas of today appear in our daily life. In 2014, AUTOMATICA in Munich presents for the first time an exhibition area with a special focus on professional service robotics. Have a look into an aspiring industry of the future.